mentioned, we're talking about workflow efficiencies involving Inventor, Vault, and Fusion. So what is Vault, right? Autodesk Vault's a data management solution as well as a product lifecycle management solution for basically engineering content, but it can really manage any kind of content. It's also integrated into AutoCAD, Inventor, as well as has some linkage into Fusion. It comes in 2 editions, both basic and professional. If you own a seat of Inventor or AutoCAD or any of the other software that Autodesk supplies, whether it be Revit, P&ID, and so on, you have access to Vault Basic. It's really just a matter of installing it and configuring it. Professional is a paid-for licensed software, and Professional adds some additional functionality, some additional workspaces to it that just kind of expand upon the simple data management tools that Basic provides. And Basic in and of itself is an excellent, efficient set of tools for managing and interacting with your data. Anecdotally, before I worked at Hagerman, I worked at a company where I was the sole Inventor user with a group of AutoCAD users, and I installed and set up a Vault Basic interface just for myself in Inventor to keep track of all of my parent-child relationships across fairly complicated assemblies that had a lot of design reuse inside of them. And being able to very quickly go in and mass edit an entire data set to apply properties to it, or very quickly check file references in the bottom up view, things that just Windows Explorer just can't do. It really can save you a lot of hassle and time working with your Inventor content or complex parent-child relationship content. So after that, just as a quick poll here, just to kind of get a little bit of feedback from the group here, a couple of quick questions. The first big one is what CAM tools you're using, and the second is what data management systems are you working with? And as far as data management concerns, I would say the bottom level of that, we've got just a Windows Explorer environment, right, where we save files, whether it be on a server or on your own local machines. Obviously, we just talked about Vault. There are other data management solutions out there that do handle various content, and they perform very similar functions to Vault. I am a very big advocate for using a data management system above and beyond Windows Explorer. If you've ever sat through a training class with me, you've probably heard me grandstand about the benefits of Vault or data management as a whole. It's definitely advantageous for the group when you start to get into more complex data to have something in place. As far as CAM tools, right, we've got the integrated CAM solutions within Inventor. Fusion has a couple of different caveats to it, depending on how complex your operation sets are. Fusion allows for some standard 2.5 axis and some turning operations embedded into the Fusion, but you can also pay for the manufacturing extension, which gives you much more complicated tool sets for 3+2 complex manipulations of the 5th axis and so on. And I'll open up Fusion here shortly, and we can take a look at that. The obvious expansion beyond that, there are other CAM tools out there, whether it be Mastercam or GibbsCam or some older tool sets, or using the embedded CAM functionality of your NC machine. With that said, where those are polls coming along here?
Keith, I did launch the first question already, and okay. I'll share those answers right here.
Okay.
We were at about 80% answered, and these were the results.
So it looks like we've got a majority of people using Inventor CAM and then another group of people using some other CAD package or software. And that's great, right? Does that launch the second question then?
Yeah.
I'm a little new to the polls here.
Here we go.
Awesome. And we'll just take a minute or so to go through this. And while that poll is running, how can Vault help, right? So the first big aspect of it is it understands any file, right? We can load any kind of documents we want into the Vault, and it allows us to see all of the information related to those files. So not only the property information, but also the parent-child relationships of those documents. So it allows us to very quickly, visualize if I've attached an NC file to an existing document, I can see that relationship. And if I make changes, I can better understand that change. Being able to reuse the data is something I'm going to focus on a little bit in this space. So, I can essentially generate components, generate files, and use those over and over again to my heart's content. And using the design reuse functionality of Vault Basic, even's copy design tool, can really help facilitate that. The other big thing is it helps secure the data. So being able to, take all of your content as it exists, regardless of file type, and load it into a Vault interface and create essentially what we refer to as a single source of truth is really beneficial in the long term for using those files. So, a common issue with NC documents is that they are more or less stale the moment they're created, right? And so by having a Vault managing those documents and linking them to their parent files, their originating files, as something changes, we can see the dates of those changes. We can see the dates of the creation. We can even go as far as linking the lifecycle process to those documents. So we have a better understanding of when we need to move those files, when we need to copy them. So some kind of workflows for Vault. We can, create sandbox components or objects that we can reuse on a regular basis. And we can use the Vault to help streamline the creation of secondary files, right? So using a Windows Explorer environment, it can be a little bit difficult to do this process. And the dominant reason for it is the parent-child relationships of the parts themselves. So if I were to perform these operations as far as like creating a copy of a fixture assembly and then open that up and start making changes to it, I really run a high risk of editing the original files and not editing the new documents. And in all reality, I would have to do a bunch of component replacements inside of that fixture assembly in order to make sure that I've got the correct files loaded and linked. And beyond that, making sure that things like part numbers get updated or any other pieces of metadata get updated, I'm manually doing that. So you're potentially running into a lot of, issues or errors with that workflow. With the Vault, I can very quickly grab a data set, tell it to make a copy of it, specifically specify within it which components I need to copy, give them new names, hit the go button, and it does all of the reattachment and reassociations in the background on its own. At that point, I can then open those files up and start making the changes I need to them. So just a quick screenshot of the copy design interface. And in this case, this is just a double-sided vice base that I've said, okay, I need to make a copy of the assembly. And in this case, I've got some jaw parts in it that I need to modify to hold a component in place. I then slapped a quick suffix on them. I hit the go button and I'm ready to start working on the files. Comparing this to, a non-Vault environment or a Windows Explorer environment, I would need to open up that double vice, confirm that the files are the correct files, and if they're not, go in and use the component replace command to swap them out, paying very close attention to which files I'm grabbing, potentially resolve issues with connections or constraints, which shouldn't happen, but variable could if I grab the wrong parts. While I'm doing this, I could also grab things like blank components. If I have a stock object that I want to use as a reference solid, I can grab that file and make a copy of a sandbox version of it. And by sandbox, I just mean a starting point, a template of sorts. And by having those objects in the Vault, again, I can make quick copies of them and then insert them into my assemblies as needed. The big trick of all this is that because we're making unique objects for these components, we can use them to help generate those fixture plates, essentially generating a functional model for our design. Same thing with the blink component. So that stock object that I'm working with, I can use some intelligence when I'm creating it called adaptivity, essentially linking that blank or that stock object to my component in question, and it can grow and change size accordingly. So with that in mind, let's go take a look at that workflow in Inventor. So the first thing I want to do is take a look at my vault objects, and how I organize the data inside of a vault is really up to me, right? Up to the company or the group that's working with it. But I can organize this data any way that I see fit. So in my case, I've kind of split this up between Inventor, CAM, and Fusion. And then inside of this, I've just got some various substructure to keep things organized. And in my Vice library, I have this standard Vice that I want to use downstream. So with this, I also want this blank component that is my rectangular stock. And these again are what I refer to as sandbox components, where I'm going to make a copy of them or an intelligent copy of them for each design as I move forward. So from here, I'm just going to bring up and show some content. There we go. So I need the Vice and I need that rectangular stock. So with those two components, I'm going to make a copy of them. And within the stack here, I really just need to specify what objects need copied. So I know I need to modify this, the center jaw, and by jaw plates, and then that rectangular stock. With them all selected, I'm just going to tell it where I want to copy them to. Now that I've done that, on the right-hand side of this naming convention dialog, I really just need to make a couple of modifications regarding how it's naming the files, because I don't really like that copy of, so we're going to take that off. And to save you guys from watching me keystroke, I'm just using housing top side A. Now I could physically come in here and modify all of these names completely as I see fit. So in this case, I missed a hyphen in the naming convention. All I need to do is go in and modify it. And again, I can clean this stuff up as much as I want. Renaming files within the vault, copying these components like this, it's never going to break a link. In fact, we typically tell people, once it's vaulted, if it's vaulted clean, it stays clean forever. So in this case, renaming them, moving them around inside of my vault structure, none of that really matters. It's going to reference and update itself accordingly. So in this case, I've specified how I want to rename these files. I do have some additional rule sets in here. I can do things like I want to rename these, or not only rename these, but also update their part numbers. I could also do things like reset the author values and a whole litany of other steps. But in my case, I'm good to go. So I can see where it's sending them, what it's calling them. I'm going to tell it to execute it. When it's finished, we'll get check marks to show us that it's completed the task. This dialog box stays open in the event that I wanted to maybe go in and modify the HTA to give me the HTBs for these components, right? To give me the bottom side or the side B of this operation set. And again, I could just modify the suffix, hit go again, make a whole nother set of copies. But from this, I'm finished. And if I go over to where that file was stored, we can now see that I have an intelligent set of copies specific for this instance. And if I touch these, we can check the parent-child relationships, and we can see that it made copies of the components that are relevant, but it's reusing some of the components that are standard across all of my fixture setups. So in this case, the sliding jaw, the base plate, the main body of this Vice setup, all of those objects are still being reused from their original instance. Now, I also have Vault Professional in play. So Vault Professional is paying attention to the life cycle of files, and the majority of these components are already released for production. All of the new components that I've created, they're also a work in progress, so they are editable to me. And within the Vault, we can configure how these life cycles function, and we'll talk about that a little bit later. Just know that these files are editable, these ones are not. So with that being said, I've got my components made as far as my stock component for this design, the fixture base. I've also got the housing itself that I'm going to work on. So let's jump over to Inventor and put all this together. Within the vault or within Inventor, the first big aspect is that I have a new set of tools, and they're really not much different than the standard tools. They're just pulling them from the vault interface. So if you're not familiar with the vault, the big thing about it is we can go grab files directly from our vault server, and it's going to pull them down to our local machine where we've kind of configured it to function in the background. But I don't have those files. Like my local machine where I would pull files from, it doesn't have any of those documents I just created. So we're going to use the place from vault option instead. From here, I can navigate to that folder, find the file I want to load, and open that up. Other than that, it functions the exact same way, right, as far as the Windows operation is concerned. But from here, I'm just going to drop one of these into the model. And for now, this component is kind of fixed in place. I told it to, right? I need to make it flexible so that it can open up. And so when I made this assembly, I kind of paid attention to the fact that I knew I was going to need to adjust these clamp positions to accommodate a component dropping into them. So we made it flexible. We left that constraint off. With that being said, I've got to go grab a couple more components from my vault. I need the stock block and my housing top. So we'll grab both of those and bring them in. And in this case, the first thing that I want to do is I want to link these two together and line them up. And you can see here that that block, they're very similar in size, but the block itself is not quite the right dimensions to fit that component. And that's fine, right? I'm not super concerned about that yet. When I'm working with this, I'm going to add a bunch of constraints to tie these together. And using a really easy trick within Inventor, I'm going to tell this block, the stock block, to be adaptive. As I do that, I'm making an edit to the file. And when I make edits to components, I need to have ownership of them within the vault. And so it's prompting me, hey, do you want to check this file out? Now, in all reality, if I were working in the vault in a real world scenario, I would tell this thing, don't prompt me for this, and just hit yes to this stuff. And just get these dialog boxes suppressed so that it's doing it all in the background. But for the sake of demonstration purposes, these dialog boxes are kind of there to visualize what's happening, right? So I'm going to check this file out. It's also going to prompt me to update the properties. Again, another dialog I can suppress away. And as I do that, I now own that file and I'm making active changes to it. From here, I just need to make a bunch of constraints. So we're just going to specify all of our offsets. And this step will take me a moment because there is several of these that I got to do because I have to do every side of the model. Now, it doesn't look like anything's changed yet, but when I do this next constraint here and I apply that 1/8 inch offset, we'll see there that the block grew or stretched to accommodate the size of that component within the model. So this last one here, I'm just going to separate these a hair. And then this one won't really be able to visualize it. So again, as I adjust that, we can see there the stock object grows, shrinks, adjusts accordingly for the base object. Now that I have that step completed, the last thing I need to do is kind of get it positioned in the model where I want to put it. So just a couple more constraints to do that. So now I've got this almost fully constrained. Let's get this side locked in. And there we go. So now I've got those two components overlapping in the model. I've essentially positioned my stock block into my fixtures where I want that to land. And in doing so, we can see that there is a visual overlap, right? I punched in a bunch of negative numbers to cause these things to overlap. That was more or less my intent. So from here, I'm just going to quick save this model. And then I'm going to make some edits to these individual components within the set. So to do that, I'm going to get down into my part level, edit this guy in place. And once I'm here, I'm editing this part in the context of the assembly. There's a really neat trick for getting data out of this assembly into this part file. And all we need to do is use the copy object tool. And it's kind of buried by default. I don't really know exactly why, probably because they don't want you to inadvertently do this when you don't want to, but I can select other solids from the assembly file and bring them into this part file. And in doing so, again, I'm going to need to check it out. It's going to bring in that block of solid. From here, I can use my combine command, switch it to subtraction, and tell it I want to subtract from that block this block. And in doing so, it cuts away that geometry. Now, from here, I could continue this process, right? Going in and maybe putting in relief corners, modifying these by pushing them or pulling them by some small amount to make sure that there's enough clearance for that component to fit in there. In the event that my stocks aren't all perfect, whatever other additional edits I might want to make to this solid. But that first step is really, really helpful, right? Being able to use the copy object and the combine command simplifies the creation of these, and it ensures that it's exactly the same size from the assembly into this model. From here, I can finish that edit. I'll repeat it on this file. The one big trick to this, make sure you tell it to use the solid option. If you leave this as surface, the combine tool won't work because it's not watertight. It's not a solid, right? And there we go. So finish the edit. And then again, we can see there, we've got our definition built up as far as those fixtures are concerned. So from here, again, I'm just going to save this file and I want to start getting the setup completed. I'm not going to go through a lot of the steps as far as defining this, but the setup of a fixture-based assembly does have some extra options in it that at least I want to talk about. So on the CAM side, I'll jump into my setup. As we can see, it generated a stock block that's the entire assembly. Not really what we're after here. So I need to switch this to model and select the actual part in question. And then in doing that, it shrank a stock object around the entity using just generic offset values, but I already have a stock. So we're going to switch this to from solid and then choose that stock object. And that lines it up to coincide with our solid object that we created. The last setup in here, I do have fixture objects in here. So I'm going to turn on fixtures and then specify all of my fixture objects around these components. Now I could go in and also define where my fixture attachment face is. In this case, the fixture attachment could be, the very bottom of the component, some other location in the model. This step is not required, but it does give me the ability to define where that fixture is located in my model. And there we go. So now I've got my setup completed. Realistically, at this point, I don't need to see this stock solid anymore. So I would just come in and turn the visibility of that off. Now, as far as vaulting is concerned, we do have a second tab up here. Just like we have a CAM tab, we now have a vault tab. And really all this is showing us is the status of all the various files that I'm working on within this specific session. So from here, I can see that stock object has been updated and it's got a save that's been stored. Same thing with the center jaw and jaw plate A on that one side. The top file has not yet been vaulted, right? And it notes that with these symbologies. So it gives you a little visual indication as to, what the status of these files are inside of this model. So I'm just going to quick check this in. And as I check in the top level assembly, it's going to check in all of its children along with it. And it will then obviously check those into the vault. So I don't own any of these files anymore. So if I did try to touch this and move things around or make edits to it, it's going to prompt me to check those files out. Again, it's keeping track of who has what when, and there's an ownership step as far as checking out the files in order to make those edits to the documents. Once I've made the edits, I can then save the changes and push them back into that single source of truth. And just taking a look at the vault, Let's close that out. Refresh my view here. We can see that document's been created. We can see all the usage of that file as far as what components are referenced. So my original component, all of the individual files that are inside of it, as well as my stock object. This also has a history of every change that's been made for this file. So right now there's only one version of this document, but as time goes on, I jump back into it and I start to add in the additional operations. Maybe I modify the component setup to, maybe make a pattern of this, or I bring in the side B setup inside of that data set. That assembly is going to get changed, and all of those changes, as I check them into the vault, get recorded in that history page. The other big benefit of this is that those documents still exist, right? So a lot of people don't use the old versions folder very often. And it's probably because their projects aren't set up to really define them well. But the vault stores every version throughout history of these documents, regardless of the scale of the change. And so, if I need to go back in time 6 months, a year, and go see what it looked like at that point in time, I can grab that old version and say, give that to me instead, and open that up and review that content, or even make that the current version of the file. So you have a lot of flexibility with the history of the documents within the vault itself. So what we just saw was Vault Basic and Inventor kind of working together. And Vault Professional adds some additional caveats that I've kind of alluded to, right? Where the documents themselves are part of a lifecycle process, and it's part of a release system, right? And that release system typically adds a level of control or security to the files. And that layer of the onion, based on what lifecycle state it's in, usually locks people out of working on the documents. And that's kind of the intention, right? I've released it, I'm done working on it, and I don't want any unintended changes to happen to that file. So we set the security. The problem is that it's really out of the box, it's really geared towards the engineering release process. And if we're trying to apply manufacturing processes to those components, it can kind of get in the way. By default, that release state locks everyone but maybe one or two administrative accounts from making any kind of edits, regardless of the scale of them, to those files. You can't even check them out. And so how do we get around that, right? There's a couple different ways that we can do it. And the first we just saw, right? In that instance, that housing top component was in a release state. It was set to not be editable. And if I were to open that file up with my account, my day-to-day Vault account, I couldn't even check it out. If I tried to make changes, it would tell me that the file's locked and that edits are prohibited. So I wouldn't be able to make those edits and get them back into the Vault. But that's not to stop me from using that file in another file, right? In an assembly, for example. The new assembly file is exactly that. It's new. It's in a work in progress state. It's in an editable environment. While it's in that editable state, I can do whatever I want to it, right? I can bring in other objects like that stock block. I can bring in all the fixture stuff. I can set up all the CAM operations and output my NC files from that assembly, referencing a locked file, right? The other way that we could do this would be I could start up a new part file and derive in a component and use that derived component as one of my locked objects, right? I'm simply creating a parent-child relationship between the file I'm working in and that released document. The file I'm in is completely open to me. It's editable. I can make whatever changes I need to it and continue on. And this, again, is another really easy way to utilize a component and potentially model a stock around a component that exists, and then do whatever kind of edits I need to make to it as far as the CAM operations are concerned. The other way, kind of on the more of an administrative way, would be to take the release process and kind of manipulate it a little bit to allow components to potentially be partially released. And that partial release process could kind of look like this, right? So this is a dialogue that or a diagram that I generate for my Vault configurations. And the way to think about this diagram is that each one of the boxes represents the various states that a file can reside within inside of the vault. And each arrow, whether it blue or red, the color means nothing, is the transitions from state A to state B. And the idea behind this is that within each of those states, there's a level of security that goes on. And so instead of having a single released state within the vault, we could in theory have two released states within the vault. And the idea is that the release to manufacturing is the step that the manufacturing users now have access to the files where they can then do all of their setup and operation definitions and even output new files and attach whatever other miscellaneous files to the documents. Once they're finished working on those documents, they can then change the state and push those documents from release to manufacturing to release to production. The names of these can obviously be changed as required. And as you make those adjustments, as you make those edits, you can, force the system to, perform other operations. For example, when a file gets pushed from review to release to manufacturing, we have a number of triggers that can take place during that transition, again, from review to released. Typically, that would be where we would start creating output files, right? So we could generate some PDFs or generate DWFs from the document set. In all reality, with the newer versions of Vault, we can also output neutral solid files. So if we have third-party applications that are, needing the CAM data, we can output those files to have them accessible. So we can then import that step or IGES into, Gibbs CAM or whatever. Once we're done working on all those files, we vault them, we push their states, we move everything into release to production simultaneously, and then they become quote unquote truly locked within the vault. The general idea behind this is, this does require a bit of, I'm going to call it reconfiguration of the vault, but it can really help when you're starting to fully integrate both the engineering workflows as well as the manufacturing workflows into under one hood. The other big thing that I'll mention here, and I didn't make a slide for it, but the vault also handles change order process. And technically nothing is really stopping you from generating a change order process for manufacturing requests, where the engineering users could go in and say, okay, well, I've finished developing these components. I need someone out on the shop floor to A, verify it's manufacturable, and B, generate the NC files for it. Or whatever manufacturing documentation is required. We could then have that digital request in the vault and linked to any files that we load into that system. And it can all happen simultaneously with the process of working on these documents. So if you have, a physical writer that, like an envelope for an engineering change that gets handed off from person to person, we can completely digitize that process and store it forever. And that's it can be a huge time savers and make it more accessible. Who's got this document is kind of a silly thing to think about in 2024. Whereas obviously being in the vault, we can very quickly jump to it. So with that being said, let's go take a look at some of those functions. So the first thing that I'll note is I am logged into my vault with 3 separate people, and down in this bottom right corner, you're going to see that change. So my administrator is essentially an admin account, right? So they have keys to the city and everything is editable within this space. However, if I switch over to my account and I look at that same folder, we can see that that document is locked to me. And the reason it's locked is that it's in this release to production and no one is meant to be editing these files. These other components I've finished working on, at least getting it set up within Inventor. So I need someone on the shop floor to continue working on these files. So I'm just going to grab these documents and change their state. And within this process, the real big thing is, what states do we have available to us? And again, this is all secure, so we can define, or it's all security based, so we can define which users have access to change from state A to state B. And in my case, I want to move these files from their current state to a specified state in here. Let me switch over to shop account. What's going on here? Let me just grab the top level. Oh, bear with me for just a second. Something has broken. So this is the under the hood dialog box, and this controls all of the transitions. So they're currently in a work in progress state. So we're going to make sure okay. And we're going to put those people back in so they can change that state. All right. There we go. So again, in this process, I can then change the state of the files from an editable work in progress to locking them or marking them as release for production. I could again do the same thing with release to manufacturing. However, I need that lifecycle process to function for these documents. And as I start to make those adjustments, it will change the state of the files in question. And if I do a get on these to update my local copy, we'll see that those red symbologies update to the locks to prevent me from making edits to those files. A couple other big things to note here. Obviously I can edit the states of these files to work on them. If I go look at this component here, we can see that it's already been released to manufacturing. The shop account has access to make edits to this file. My account does not. Right? As an engineer, not in manufacturing, we set the securities based on like group policy, and that in turn controls who can do what when. And so in the Inventor side, just make sure I'm logged in as the right person here. I can now come in and start a new part file. And then from here, I want to derive a component. I can then go grab that object and bring in that solid body into a new design. This new component is, accessible to me as I see fit. With that component created, I can then start to do things like generate new sketches, project geometry as required from this shape. So I'm trying to be very precise with my pick-ins here. And now that I have those profiles selected, I can then use those in my sketch to generate a new profile. Now, in my case, I'm going to be a little precise here. So I'm going to quickly just generate the top surface of this part. So to do that, I'm going to use a boundary patch. And as I start to select these boundaries, it will create a singular surface using those as a guide. Now that I have that created, I can tell the system to extrude this to a specific face. Now, in my case, it's trying to generate this as a modification to the existing object. And in my case, I want this to be a new solid. So I'm just going to tell it to make a new solid to that surface. And in doing so, I end up with a new stock block inside of this part file. So I've got the part and the solid that I pulled through. And again, the general idea here is that if I've already got a stock object or I've done all these outside manipulations to this shape, I now have a part that I can then start to work with for doing all the interior cuts of that surface. And again, I could add any other number of features to this. So if I needed to, put a tab on it or, other flat surfaces on this, again, it's really up to me at that point how I need to manipulate that shape. But again, all I did there was I used the derive command, and then I stole some geometry off the top and some geometry off the bottom and use that geometry to create a new solid. This part is its own unique part. So from here, when I save this, I'm just stealing the name because I'm lazy and don't want to type. Right? I can make that new component as required. This new part, as I check it in, it gets its own new process. And this file is completely editable to me, to my heart's content, right? So I can work on it, make edits. I could even do all the CAM operations in it. And that original file is still released, still locked out. And once I have all these objects completed, I can then change the state of them, push them to that release to production to denote that they're completely finished. So what if I already have CAM data that exists, right? So what about all the other stuff, right, that goes along with these objects? I can get that data into the vault very, very quickly. So in this case, I've already got this wheel hub, the geometry and stuff created for it. So I'm just going to navigate over to it. And in here, I've got the NC file and a setup sheet for it. And these files are output documents from the CAM operations, right? So in this case, I can grab those, and all I need to do is drag and drop them into the vault. Now, some of this is going to automatically get categorized within the system. So we can see here that this is a program file. So it knows it's watching for NC documents, and it's going to apply that to it on its own, right? I could do the same thing to this file, right? We can see here it's a base object, and I can categorize this by simply changing it and telling it it's part of the program set. Now, as it stands, these documents are just kind of hanging out in my vault. They're not doing anything, or they're not associated to this file. So if I want to attach these, all I need to do is select the file in question, the attachments, and then I can go browse for other documents to attach to this file. So from here, I just hit the attach button, select the files I want to attach to it, and add those files to the document. And as I do that, oh, excuse me. As I do that, that adds those files as reference attachments to that component. And all of the dating of that information is all stored. So downstream, as I start to make manufacturing edits to this wheel hub, maybe I go in and I revise this document by simply moving it from its current state back to work in progress. We'll see it moves from Rev A to Rev B. I could then, in theory, open this up, update all the NC operations on it, update sizes of holes and things like that. I can see in here the date and times of those files. Now, I could take it a step farther and also revise these documents, essentially attaching that lifecycle process to these files as well. And in doing so, we would see that these are still marked in Rev A. And then it gives me a visual clue that I need to output new versions of these as Rev B and push them into the vault. We can also store any file type within the system. So it doesn't necessarily have to be Inventor files and those other miscellaneous output files. So out here, I've got a number of NC files. Again, I can just drag and drop those into the vault for safekeeping. I've also got a bunch of master CAM files, right? In this case, I can very quickly just grab the entire folder and say, put it in this directory. As you check in files this way, it does give you a quick prompt for, how do I want to, what am I putting into the vault and why? And so I can very quickly just add notes on it, and it keeps track of that notation. So ICI just stands for initial check-in, but in doing so, it creates that master CAM file folder with all of our documents in it. So the vault really is CAD neutral as far as managing files within the system. It doesn't really care all that much about whether it's a Mastercam or a SolidWorks or an Inventor or AutoCAD file. It'll pull them in, right? And we can work with them. And we can go through all of the master or Vault professional functions of these documents. So if I wanted to change the properties or change the state of them to move them to released, I can do so. And use the security of the Vault to manage who can edit them and when, and who can transition the files and when. So what about Fusion, right? So Fusion, previously Fusion 360 is a cloud-based software that does CAD, CAM, PCB definitions, CAE or FEA analysis. The files that are created within Fusion are stored in the cloud. And that potentially could interfere with the Vault interacting with those documents. But the Vault has a set of tools embedded within it that allow us to essentially sync to the cloud folder structure. And it does require a little bit of setup, and that's where the desktop connector comes into play. So what the desktop connector allows us to do is we specify in the Vault where we want to, we specify in the desktop connector where what Fusion folder, what Fusion drive we want to work with. We then specify in Vault to sync to that location. And once we've done the synchronization of it, it's really just a matter of uploading the files from the Vault to the cloud. We can then open those files in Fusion and do whatever stuff we want to do to them. We save the changes. We're then able to push the files back down into the Vault. So it gives us essentially the ability to integrate our Vault to the cloud space. And by doing that, we can actually push data to users outside of the company if necessary. Again, it does take a little bit of setup, and it's not necessarily automatic. There's a synchronization timeline that happens, or a synchronization schedule. And I'm going to show you where the buttons are, at least to show what to set up inside of the interface. But showing it in real time is not necessarily all that feasible. But if I were to go to a file that I want to work with, I can select that file and tell it to upload to the cloud drive. And as I do this, it essentially tacks a task to be performed in the future. And the way that this tool works is an administrator needs to first go in and define that collaboration location. And within this space, we really just specify, okay, well, this is the Fusion team that I'm working with. This is the data that I want to integrate to it. And this is where the file is in my Vault. So in this case, this specific location is being synchronized to my cloud. And if I go look at that folder, we can see I've got an Inventor part file in here that I've already uploaded to the cloud drive. And if I click this, it won't kick that error. But I can then tell it to upload it. And then at some point in the future, and you typically set it to run like every 8 hours, you can also force it to run on demand. But it then gives me access to that Inventor file in that project. So I'm in my Fusion team and I'm in that specific project, and there's the IPT file. So from here, I can access this document, open it up, and start working with it within Fusion. So as I mentioned, right, Fusion has a number of manufacturing functionality embedded within it. Some of these tools, however, are extra. They are part of the manufacturing connection. And that manufacturing connection does have an extra cost to it, but it adds a huge amount of advanced functionality. For example, the ability for the system to recognize all of the holes in the model and automatically apply drilling operations to those objects. The multi-axis functionality, as far as being able to control, advanced swarfing or doing multi-axis control, doing rotary parallel operations, rotary contour operations, all of these are specific tools in the add-on. So a couple of big differences between the Fusion manufacturing space and the Inventor CAM manufacturing space. The big one that I've always noticed is the way that it handles the tool library is very, very different in Fusion. So just to kind of open this up for a moment, in looking at the tool library, if I look at a specific set of tools, not cutting, go down to filling. Within this, we have one set of tools, and within this specific object, as I select a specific object, say a flat end mill, instead of having a library for every different type of material, it has cutting information based on a specific material. Now, it's not watching for this aluminum. It's not also watching for like the slotting. It's just how we want to define the settings for it, right? But this is substantially, in my opinion, substantially better than the way that Inventor handles this library data. It doesn't care that it's the same tool for every one of these operations with different speeds and feed rates defined. And so when I go to use this tool, I specify it's a flat end mill, but then I also pick which speed and feed rate I want. And so you could have in here, these definitions, whether it's roughing or finishing, but you could also set it up for just, this is this machine and this is the settings that we prefer to use for this machine in these types of operations, and have cutting data defined for it. Doing it in Inventor, you have to have a library for each one of those, and then in each library has each of the tools. And so it's more or less backwards, right? One is tool, then speed and feed rate, and the other is speed and feed rate, then the tools, more or less, right? And so this has been very, very modified. It also has the ability to quickly download from vendor libraries. And obviously we can create our own tool libraries as needed. If we create a local tool library, we can modify it. We can also save that file off. It's a local file, and we could vault it, right, for safekeeping if needed. In the event that somebody gets hairy and decides they want to do something weird to the library, we have one for safekeeping. But that's on the very front end of the process. A lot of these other tools, as far as doing facing operations, whether it's 2D adaptive steps, doing clearing or contouring, all of these function almost exactly the same as they do in Inventor. As far as the steps required, the options available, there's really only a small handful of additional functionality inside of here that you don't get on the Inventor side. So it's really they're almost technically comparable. The dominant difference is that by default, it's saving files in the cloud, and there is some additional expanded tools within the extension, the manufacturing extension. But from my experience, your overall workflow inside of Fusion and inside of Inventor are nearly identical. So the big thing here is that once I finish this process and I'm done working on this document, I would then go back over to Vault and I would select that file and I'd say download from Cloud Drive. And then after a small period of time, it would then reflect to show me the version change to that document. So in this case, I had originally created it. I then worked on it in Fusion for a couple minutes and then re-downloaded the file. And again, this gives not only the ability for anyone on Fusion to work on it, it can also be people outside the company. And once they're finished working on the document, I can then pull those changes back in. So I already talked about the post and NC files. The big thing about these is that nothing's technically stopping you from putting all of these documents, your posts, as well as your output files in the vault, right? And so, in loading them in the vault, we can support any document type, and we can keep track of them using all of the vault systems as required. Okay. So I'm running a little bit long on time here. Just getting into the Q&A here. Are there any questions that have come up in the? I don't see any questions. Oh, they're all shit. Were there any questions?
This is Clayton chiming in. I haven't seen any questions come in yet.
Interesting. Well, if you do have questions that come up in the future, or if you want more information about how the integrations between Inventor, CAM, Fusion, or Vault work together, feel free to reach out to us. And obviously you can use hagerman.com/contact if you're not certain who your sales representative is. We'll be more than happy to help you out, getting you set up with the Vault, getting you set up with Inventor, CAM, or Fusion. It looks like one question popped up. With Fusion, can you tell it not to default to saving to the cloud? No. Fusion is a cloud-based system. And so as such, the files default to saving on the cloud. You do have the ability using the desktop connector to create a shared linked location to a local location, but it's not a default setting. You have to go through the process of configuring it to basically just make a copy of them to your local machine. And if you do set up the desktop connector, which it kind of hangs out down here, it shows you whether or not there are tasks that need to run. Additionally, in your Windows Explorer, you will then get some additional folders that show up. You should have the job in it. Come on now. So there's my Fusion team. And this is probably going to run a little slow because, again, it is reaching out to the cloud. But there's that Fusion project. And then once this loads, we should be able to see the files in it. So all this is doing is it's synchronizing the files, showing me what's on the cloud, what's been synchronized. And from here, I could, in theory, I could pull these files either into the Vault or, just leave them where they are. The Vault desktop the Vault desktop connection tool is really what's linking the stuff together to between the Vault and the cloud. Well, I thank you for everyone's time today. Hopefully this was insightful to see how some of the Vault functions can help with the CAM operations within Inventor and Fusion. And again, if you have any questions, feel free to reach out to your sales representative.
Yes, thank you everyone for attending. Thanks, Keith, for the presentation. And look out for the email with the recording link that you can watch again. Thanks, everyone. Bye.